In this video, we're going to look at finding an angle that bisects these two vectors. And then after we find that angle, we're going to figure out the vector that bisects that angle between the two given vectors. The first thing I'm going to do is I'm going to draw a rough sketch, and I really mean a rough sketch, of what these two angles are doing, or what these two vectors are doing. So I'm going to label these. I'm going to label the first one A, and I'm going to label the second one B, and I'm just going to use colors so it just makes it a little easier to differentiate the two. Now it's in 2 dimensions. I only have I and J. I don't have K, but this would work in K as well. First thing I'm going to do is draw what A kind of looks like. So 12 in the I direction, 5 in the J direction. So this is very poorly drawn. Let me try this again. This is what A would kind of look like. And then B is 8 in the I direction and negative 15 in the J direction. And so it's going to look maybe something like that. What I want is, I want this vector W. So I'm just going to say this is vector W. And to find this vector W, the first thing I'm going to do is I'm going to find this angle. I'm going to call it theta. Theta is the angle that is formed between A and B. And when you find theta, it is by default the smallest angle of the two. And you're saying, what do you mean the two? Where this other angle is this that I'm drawing. That's another angle you could find, but that's not the one we want. We don't want that one I just drew in yellow. What we want is that angle theta that I just wrote. And so that's what it means here to find the smaller of the two angles that are formed, because this angle that I just erased is also formed by these two, but we don't want that obtuse. We want this angle. And so the way that we find this angle is we have a formula. If you're following this from Calculus 3 using the OpenStax book, this is Calculus 3, OpenStax, section 2.3. We have a formula for it, and I'm just going to write it as theta is equal to. And rearranging this formula, I get the cosine inverse of the dot product of the vector A and the vector B divided by the magnitude of A and the magnitude of B. Now, it's preferred to use radians, but it's not the end of the world if you're like, man, I really like degrees. I'm going to give it to you in radians. And we get the angle theta to equal 1.47563 radians. Now, that's not going to give me what I want. It's close. We're getting closer. It's a step closer, but it's still not going to give me what I want because I want the angle that bisects it. So, okay, so I'm going to take my theta and I'm going to divide it by 2. When I do that, I'm finding either this angle or I'm finding this angle. This is theta divided by 2. So I'm going to take that number, divide by 2, and I get 0.73782. And before you ask, I'm rounding as I go. So I'm doing some rounding here. I'm going out several decimal places, but I am rounding, so I know these are not exact answers. Now, that's still not going to give me the angle that I need. The angle that I need is I need this angle right here. I need to know how far off the x-axis W is. I'm going to call this alpha. Alpha is the angle that I need, so I can figure out what that vector is. I can do this one of 2 ways. Either I can find the angle that is formed off the x-axis to A. We could call it beta if you want. We can find this angle beta. Then I know that alpha will be this angle, and then all I have to do is subtract off beta, which is the angle formed from the x-axis to A. And then slap a negative on it because I need to be down in the 4th quadrant. Or I can find the angle that is formed between the x-axis and this vector B, and then I could subtract off theta divided by 2, and then I'll find this angle alpha. Again, make sure you put a negative on it because you're in a negative rotation. You're down in quadrant number 4. Doesn't matter. So I'm going to find the angle that is formed off of the x-axis to A. So from A to the x-axis, I'm going to call this angle beta. And the reason I'm going to call it beta is because what I'm really doing here is I know that if I take theta divided by 2, subtract off beta, I'm going to get that angle alpha. Now, of course, it's going to give me a positive number. It's going to give me a positive rotation, but I am in the fourth quadrant, which is why I drew my vectors. So I knew whether or not I had to add pi to it or anything to put it in different quadrants. So I know this angle will be positive. In the end, I'm going to put on a negative rotation, put it in quadrant number 4. So I have to just find this angle beta. All right. And I can just use the same formula I used up above. I'll call beta to be the cosine inverse of the vector A, and then the unit vector in the x direction. Well, the unit vector in the x direction, and this will be dotted with, the unit vector in the x direction, which is, we know the unit vector in the x direction is just the vector 1, 0. So I'm going to use that vector, which is the x-axis, a positive x-axis, to do my cosine inverse. So I'm going to just call this I, because I'm just going in the I direction, divided by the magnitude of A multiplied by the magnitude of I. Well, we like the magnitude of I because it's just 1, and that makes us really happy. So magnitude of I. All right, so I'm going to do this, and I get beta to be 0.39479 radians. Now, if I didn't want to do the same formula, I could have just done the tangent inverse, right? Because I know that my vector, I went 12 in the x direction and 5 in the y direction, so I can also find beta doing the tangent inverse. So back in pre-calculus 2 type stuff, and it's 5 divided by 12. Either way, I get the same value. Again, this is just an intermediate step. This is not what I want. What I want is alpha. But I know that alpha is going to be equal to the 0.73782, subtracting off the 0.39479. Now, I want this to be negative. This answer will be positive, so I could have just subtracted the 0.73782 from the negative, or from the 0.39479. It doesn't matter. I just know that when I get done, I need alpha to be negative, so I'll do a negative alpha this way so that we can get alpha, because I need it to be negative. And so I'm going to take my theta divided by 2. I'm going to subtract off my beta, and I get alpha to be 0.37302. I'll stop there. Okay. And it's a negative. It's a negative rotation. Now, this does not give me my W vector, but we're almost there. There's one more stop. So we know that our vector can be wrote as the length of the magnitude of W, or if you want to think about it in pre-calculus 2 terms, the radius, multiplied by the components that make this a unit vector, which would be the cosine of alpha, comma, the sine of alpha. So W, we don't know what the magnitude is, so let's just assume it's the unit vector. So let's make the magnitude equal to 1. So then this is just going to be the cosine of negative 0.37302, and then the sine of negative 0.37302. Parentheses there. Okay. So now, a little bit of OCD kicking in there. I have to have the right, okay. So now there's my vector, and I can leave it like that. If they want the vector in the unit vector form, which is the i's and j's, then all I have to do is do the cosine of that angle which is 0.9417 in the I direction plus, now I'm going to do the sine of that angle. So just doing that on my calculator, and I get, and that should be a negative 0.33634 in the J direction. And now I've found my angle. And I'm sure there's probably easier ways to do this, but this is how my brain thinks. And it's like, oh, okay, well, if I can visualize where the angle is, and then I can find that angle, divide by 2, and then I just need to find the angle that is formed between one of the two vectors to the x-axis. And then I just have to find that difference, and then remembering to put on a positive or negative on the angle, just depending on, or maybe even adding pi, depends on which quadrant I land in. And that's it.